I think we're going to get started. Welcome everybody here to 32BJ. My name is Lenore Friedlander. I'm the assistant to the president here at 32BJ, and we're really excited about the program tonight and the turnout. Looks like we have are putting down some more chairs. This is the first this year in a series of forums and discussions that we're going to have about important topics that is a partnership with Urban Green Council. And so we have a diversity of people and experience in the room that I think is going to make for a great evening. We have members of 32BJ who work in buildings, operating, maintaining, running buildings. And for those of you who aren't familiar with 32BJ, we are a labor union that represents about 150,000 workers in 12 states and the District of Columbia. And here in New York, we have about 70,000 members in residential buildings, in commercial buildings, in institutions, in transportation centers who do the operations, maintenance, cleaning, security in buildings, and have a really valuable perspective to bring to this conversation about people who actually operate and maintain buildings. And we also have people from architects, designers, engineers, and others associated with the Urban Green Council who also bring a really important and valuable perspective. So we're really excited about the program this evening and hope that to invite everybody to participate in this conversation. And one of the things that's important to us as a union is that we create space to talk about important issues, including climate change and how we increase energy efficiency, how we work together to create a sustainable and an equitable world. And so we're really pleased that we have this chance this evening. I should say that our union president, Hector Figueroa, is now on the board of the Urban Green Council. We're excited about that and contributing to the conversation. So there'll be a presentation, and then there'll be a chance for people to have a discussion and a dialogue. And I'd like to ask Camille from the Urban Green Council to come up and talk to us a little bit. Welcome, give yourself a round of applause, and we hope it's a really productive evening.
Very obediently, I am standing at the podium where I've been directed to stand. So 32BJ is such a great venue for us and such a great audience. It's been actually just about exactly a year since Urban Green had the honor of being here before. So thank you for having us again. Lenore, thank you. And thank you to all of you for coming out. We're excited about tonight. I'm just going to remind or tell you that Urban Green Council is a New York City-based nonprofit. We have a mission to transform New York City buildings for a more sustainable future. We do this through research, policy, and education work. We have events like this throughout the year. You can find out about them on our website or from our weekly newsletter. And so we hope you'll sign up for that for free and come to other events also at other venues. Tonight, Bob Muldoon is playing two roles. So he is both obviously part of your family at 32BJ. I want to get the title exactly right, as assistant manager for green building training. But he has also served for a number of years with us on the Urban Green Council as part of the monthly programs committee. And this is a committee of industry professionals who volunteer their time to help us program events like this. So this event was his inspiration, and Bob's going to come up and introduce tonight's speakers. Thanks so much.
Welcome, everyone. Welcome, everyone. This is a great turnout tonight. Thanks so much for our members signing up and turning out to this event, as well as everyone else. So again, my name is Bob Muldoon. I'm on the members program committee for Urban Green Council, but also I coordinate green buildings training here at the 32BJ Training Fund program. Our director, Linda Nelson, is in the back. So if you have any complaints, you can go straight to her. But with the 32BJ training program, we have the Green Buildings Training program within it. And our goal is to train building operators and staff in the strategies and standards of green, efficient buildings that they can use and apply in your buildings, but also that can help you develop you in your career. And I'm proud to say at this point, we have trained over 2,000 union members as BPI multifamily building operators. A good number of those have also achieved the G-Pro O&M certificate. We trained over 150 multifamily building analysts and almost 30 lead green associates, and we're working on a lead AP O&M program. So we've made a lot of progress, and we're excited to host tonight's forum on a cutting-edge technology for multifamily buildings, condensing boilers. For 32BJ members who signed in, at the end you can pick up your certificate for attending tonight's event out front, just outside the doors. And for everyone else, of course, you can apply for continuing education credit from USGBC and BPI. So as you know, condensing boilers are advanced and compact boiler systems that can easily achieve 90% efficiency in the buildings, in multifamily buildings. However, they don't work in all situations, and they pose their own sets of problems. Our 4 speakers tonight will talk about their firsthand accounts in working with these systems, installing these systems, and using these systems, and some of the do's and don'ts. Our first speaker is Bill Aristobulus, who is a 32BJ member, recently retired resident manager of a 15-story multifamily building in Manhattan's Greenwich Village for about 25 years, so he has some experience. Bill hails from the Bronx and is a proud member of 32BJ. Bill was trained in green buildings training early on, and he went on to become one of our instructors and a mentor to other 32BJ operators and staff, building staff. After Bill will be Bob Daly from the Department of Buildings. He's a technical director for the Division of Boilers in the New York City Department of Buildings. Bob was kind enough to come and speak to our classes on transitioning from number 6 fuel oil, and that's when he introduced us to the idea of using condensing boilers. Bob has also been a great ally to managers and building operators around the city in boiler conversions and similar issues. Following Bob Daly will be 2 energy consultants who have implemented a number of projects using condensing boilers. The first will be Asit Patel, who has set up his own energy management company, A&P Energy. I've known Asit for years as a very effective and down-to-earth instructor with the Association for Energy Affordability, and he is the current president of the Association of Energy Engineers. He is an AEE certified energy manager, certified energy auditor, an existing building commissioning professional, and a BPI multifamily building analyst. So he's done a lot. And then our final speaker tonight will be Sam Weissenberg, who is the vice president for engineering at Bright Power. Sam works on troubleshooting or optimizing and design of steam and hot water systems. And he is also an AEE certified building commissioning professional and a BPI multifamily building analyst. So we have some great presentations tonight, some real firsthand experience I think we'll gain a lot from. And please hold your questions for the most part to the end, because we will follow up the presentations with Q&A. We'll bring up some chairs and bring the panelists up and then do a Q&A session. So let's get started. Bill.
Okay, Bob introduced me as a resident manager, but the truth is, when a person does something stupid, or worse still, nothing at all, they get called superintendents. But, and this is the only difference, really, honestly. When a person does something smart, they get called resident managers. Look what our resident manager did, okay? The deal is that I did something smart. I forced my building, a co-op, who looks at money and looks at, I should get closer, yeah, who looks at things like the cost of things and not the long term. And I did a smart thing. I made them put condensing boilers in. Okay? So let's start at the beginning. I bought a house in 2009. This is a little boring. And it was a 1,400 square foot Cape Cod. And this was the boiler. The boiler was a 50-year-old number 2 oil boiler, 50% efficiency. What does that mean? That meant for every $100 worth of oil I was buying, I was getting 50% worth of heat. $50 worth of heat, I'm sorry, $50 worth of heat. And to make matters worse, the boiler was in a blockhouse in the back of my property. I researched replacing the boiler and decided on a condensing boiler with an indirect hot water tank. I built a partial basement to house the new boiler because it needed to be protected from the elements. I insulated every single foot of the distribution piping. Every pipe was fully insulated. I also insulated and air sealed the house. And here it is. It's a little bit bigger than a bread box. It's an amazing boiler, okay? Condensing boiler with an indirect hot water tank. In other words, that's the hot water heater on the side there. And that's where I get my domestic water from. 96% efficient. So that means for every $100 worth of fuel I used, I got $96 worth of heat. Fast forward to 2012. That was my building. That was the superintendent, resident manager, pick your choice. We had two 50-year-old boilers, number 6 oil-fired boilers, 65% efficiency. But what was worse was that boiler room, when the boilers were running, was 120 degrees. And I said, there's something wrong here. Why isn't this heat going up to my apartments? Why is it staying in the boiler room? I want it out of here. Okay. So the board decided to replace these old boilers. As they all do, they hired an engineering firm. The first thing the engineering firm specified were 2 really nice cyclonic boilers, and they were dual fuel. They burned gas and oil, 80 to 85% efficient. And it bothered me. I'm saying, why should, in 2012, should we be talking about an 85% efficient boiler? In my little stinking house, I have a 96% efficient boiler. But, you know, they're the engineers, I'm not. Hence, July 6, 2012, like who was the president? A day that shall go down in infamy. I came to a seminar here, to this building, Green Buildings Converting from Number 6 Oil, given by Mr. Bob Daly, which you guys are going to have the pleasure of hearing after I get off. Central Inspection Boiler Division, New York City Department of Buildings. After the seminar, I took him aside. I said, Mr. Daly, I want to put a condensing boiler in my building, but I'm being told they're no good. And he says, condensing boiler is the way to go. And I said, but Mr. Daly, do they make big boilers? Can I run a big building with these things? And truth be told, and the experts will vouch for this on me, up till then, there wasn't that many big condensing boilers. He says, yes, they do make big condensing boilers. So with that, I went back to my engineer and I said, hey, I want to put condensing boilers in. They're no good. They don't work. They're terrible, blah, blah, blah. On and on. I called the condensing boiler company. I won't mention the name because we're not supposed to do that. They gave the engineer a show and tell. A scant 2 hours later, the engineer was a born-again condensing boiler expert. And he said, yeah, this sounds great. Let's do it. So ultimately, we decided on these 3 condensing boilers, firing firm gas. They're not dual fuel. They just fire firm gas. 95% efficient, okay? And they're coupled to an indirect domestic hot water tank, which is really just a big thermos bottle. So what you do is any of the 3 boilers can heat the water in this huge thermos bottle, and people in the building draw from it all day long. But here's the kicker. I was just there when I took these pictures. That's how warm it is in the room, or how cold it is in the room, 75 degrees. We also installed a BMS system, which gives you information real time, which can also send via computer or via smartphone to the resident manager who now runs the building. He knows exactly what's going on at any given moment. So, a big difference, eh? So additionally, every room received individual thermostats to control the room heating and cooling units, which saved a lot of energy in themselves, because if you weren't home, the resident didn't have to run the heating unit or the cooling unit. Every foot of the distribution piping system was insulated with 2 inches of insulation. I remember having an argument with, well, the engineer wasn't really arguing with me, but the contractor wanted to put in 1 inch of insulation. I said, no, we want to put in 2 inches. What's the difference? And additionally, the walls of the chases, that's the chases that the piping goes up and down, was spray foam, insulated, and air sealed. Ironically, not only did this make the system additionally more efficient, we cut back a lot of the noise from apartment to apartment by insulating these chases. In the final analysis, we created a state-of-the-art efficient system. The building's annual heat energy cost went from about $135,000 to about $60,000. And the board gave me a big attaboy. Thank you.
Born in New York City, I'm proud of it, by the way. Went to college, got my mechanical engineer degree up at Columbia. And in the 1960s, I'm old. And at the time, people always ask me about the 60s, what was it like? Well, if you remember it well, you weren't part of it. So I really don't know a damn thing of what happened then. It's a distant memory. But if you want to reminisce, I'm welcome to it. When people first proposed condensing boilers to me, I'm a show-me guy. So, and if this thing doesn't work, we're going to step outside and we'll settle this finally. So, but I am convinced. I've seen enough good quality products to make this thing work. And I thank local 32BJ for this opportunity to speak, because the people here are part of the solution that we need. When someone proposes something, and a lot of you have proposed ideas, just as you heard, they propose the idea to someone. Doesn't mean a professional engineer or a registered architect's the smartest person. You come out with the idea. You may be the winner on this. You may get the attaboy, but you're also part of the solution to where we want to be. Part of to getting the green environment, part into using less fossil fuels. We work well together on going from number 6 to gas and number 2, and a little bit of number 4 left. But thanks to the efforts, 75% less soot in New York City. If you leave your windows open in lower Manhattan, you'll realize you're not getting the soot you used to. Asthma problem, asthma calls, asthma people going into emergencies. It isn't eliminated, it's just reduced it, and that's what it's all about. So I thank you all. I thank you for inviting me, because again, you're part of the solution. So condensing boilers. I've been in private practice in the private industry for many years, and about 12 years ago the company closed and it was moved to South Texas or hunt for a new job. Engineers are kind of durable, like all of us here probably. You get knocked down once or twice. You got a choice to start crying or dust yourself off, get back up, and deal with it. Now, you were dealing with modern technology. My recommendation is, and this is the group that's going to do it, you learn what's going on. You don't have to know everything about condensing boilers. You just have to know that they're a lot better. They're costly, but they're a lot better. And if you're the one helping out doing the solution, you can win the prize here, and you can also find out who to talk to when you got a problem. And one of the people you may want to talk to is myself or some of the other speakers. Last item is just a note that I think of. We had some really cold days in the winter. And anyone want to ask me how cold it was, Bob? Why, it was so cold that the lawyers had their hands in their own pockets. I got to throw a few in a row, making sure you're awake. Here we go, building code inspections. Now you need a permit when you replace these. So there's building code requirements. There's what an inspector will accept, that's one of my guys, and there's what a contractor installs. The purpose of the Department of Buildings going out is to be sure that when you go to sleep at night, you're going to wake up in the morning and not be threatened by any boiler. So we have an enviable record in a city of 8 million. We have 120,000 registered boilers, which at any time could cause serious damage or injury. And we've had one death from these 120,000 boilers in the last 12 years. And on that one, we noted some serious problems, which the owner said he corrected. It was at Fort Hamilton Parkway. And evidently they did not correct them well because the woman above in the apartment suffered death by carbon monoxide. So we're all part of the solution to these problems. Now, condensing boilers. When a condensing boiler works, you can use heat at a little bit less than temperature you might be thinking of. A condensing hot water heater. You have water coming in at about 50, it's going out, say 120. It's a great opportunity to hit that 96, 97, 98% efficiency. On heating depends a lot more on what type of heating you have. You need to the water has to be below really 140 to get full advantage of it. So a system, if a steam system, it's not going to work. You have a heating system designed for 180, it's not going to offer you full condensing savings except in the shoulder seasons. So you may have to do some serious changes to the fin tube in the building. New buildings, virtually 100% of the new buildings use condensing boilers. They're not the little ones, which are fine, 100, 100,000, 120,000 BTUs. You put in an individual apartment. I'm seeing loads of them. They're great, but to heat a full building, it takes a bit more. So I'm seeing gut rehabs and new buildings, virtually 100%. The efficiency is when you take the heat of vaporization and instead of having water vapor go up the stack, you condense it and you get that energy transition. So that's where your real savings are on this. If you can get that flue gas down and you can use heat in the 130, 135 range, you can save big time. Means condensate, and condensate means you're going to have acidic water, low pH. You need a condensate trap to be sure you're not blowing out flue gas. And that you have to be very careful of it. You can't pipe this in copper, even steel. It'll eat it right away. So it's plastic and a little neutralizer. It's going to be that simple. You got to treat the condensate. It can be down around the 3 pH, which is really, really low. I mean, I see copper gone in days. And you got to pipe it the correct way. What I really want to spend my time on is venting. The venting of it, you suck the air in, do not heat it, it goes right into the boiler. You burn it in the boiler and vent it out. Many units are extremely sensitive to pressure differentials. So some manufacturers require the intake and the exhaust lengths to be identical or very close. You got to read the manufacturer's literature to be sure you got it. The manufacturer's instructions talk about mounting of it. They talk about the flue products. Depending on the manufacturer, they will allow you to use CPVC or polypropylene or AL29C or some certain stainlesses. Not all stainless steel is alike. So read in the manual what products are available. You cannot use PVC. Many examples I have, which I didn't show them here, but if the PVC gets above about 145, it starts to turn bright orange, crack, and separate. It's a deadly end. What I'm working with a manufacturer now, hopefully, is little stick-on thermometers that'll go up to the highest point of gas it sees and lock in. So if you have any PVC vent, it's a way for you to check. Again, working together, we solve problems. If you're venting with CPVC, only listed CPVC, that means it's by a nationally recognized testing laboratory that's tested to a standard. I brought a piece with me. I have a small black light that shows that the glue used is the proper glue. This isn't brain surgery, but you can make pitfalls here. Polypropylene is very common today, multiple manufacturers, much lighter and realistic in price. So I'm seeing market penetration there. The steel products are quite expensive. They're rugged. They'll last forever. Again, you have to be cautious as to they're done right. There's arrows on them, and I'd say about a third of the time the arrows are facing in the wrong direction when we go for an inspection. Take a look at the manual. Make sure you, as a person in that building, because you may be the person that might be gassed with carbon monoxide, take a look at that manual and browse it as someone's putting in to be sure it's done right. Okay. More on venting. Flue gases on a condensing boiler, they're not that hot. So you don't get that natural lift. You put it into an alleyway and you're making it for domestic hot water, that flue gas may be down around 120. So it'll barely lift on a hot day. So you have to be prepared to direct that flue gas away. We capped the sidewall maximum vent capacity at 350,000 BTUs. I was seeing multi-million BTU boilers under people's windows. Now, before we kill some people with this, we changed the code. Really want to get to the meat here. Combustion air, sealed combustion. This means you draw the air directly from outside. That means above the snow line. Quick way to have a problem is if you put it too low, you can get clogged with leaves or snow or ice or anything else. So really 3 foot above is what I want. Ventilation air, if the boilers are individual boilers in tight closets, you have one per condo, one per co-op, and they're 2 inches from each side. They're mounted to the back wall with 2 inches in front. A boiler that's generating hot water at 130, that room will hit 130 and you'll fry the controls. So that boiler has to vent a bit. You can mount these in a room as long as it's not a sleeping room. You cannot put it in a bedroom. But you can put it in the living room, dining room, kitchen. You can put it all around, office. They're legit, up to 350,000 BTUs, which you're going to do one very big apartment or an office. You get above that, you need an actual boiler room. This is just in Europe, who tend to be ahead of us because, excuse me, the cost of fossil fuel is much greater there than us. Look at the UK. 95% of the new boilers are condensing boilers. And this slide is 6 years old. So the market penetration is tremendous. This slide has a lot of stuff on it, and you can email me for it. You must venting, if you're putting it outside, 7 foot above grade. That means above a sidewalk, above a walkway, above a patio. A foot over a door, 4 foot to the side of an operable window, 4 foot under, maximum 350,000 BTUs. So small devices. You got a big one, put it to the roof. That's a sketch, and I think you're going to put it on your website, Bob? Okay. Bad design. They pitched it to the outside. Those spears of ice are over 6 foot long. At the 4th floor, they'll go right through you. I don't know if everyone can see that, but this is one. You pitch it a little bit to the outside, dangerous. You pitch it inside, no issue. 2 million BTUs under a window. Not under my window. Bad design. Just spaghetti right under a window. Stupid. Ice coming out of the flue, not done properly. Condensing boiler summaries, they can save you a whole lot of money. They can be very safe. They're great devices. If you got a question, if you feel the design is at fault, call me. Call me, email me, better yet. I'm always available for the questions. I'm from New York, I speak fast, and if I get really angry, it's like, watch out. There's a glass barrier between where I sit normally and talk to people. It's there to protect the people because I get so goddamn mad sometimes. When people's safety is questioned, I have a problem. We're there to protect you, we're there to work with you. You are part of the solution. I look forward to working with you, to getting your emails. There is no dumb question ever. I'll be staying around. Come back and see me. I'll show you my PVC. We'll have a laugh. We're all in this together, and we're going to solve the problems together. That's the email, rdaily@buildings.nyc.gov. I try to answer within a day, and you can be the smartest person on condensing boilers by asking the right people the right questions. So I've had YouTubes, I have had videos, I've had everything. That's wonderful, and I keep it all down. We do things together. Last thing, if you feel uncomfortable and you want a personal one-on-one, you take the E train to 53rd Street, get off at 5th Avenue. You walk to the northwest corner of 53rd and 5th at noon on March 17th. You look for a balding middle-aged fat guy with his grandson Finbar. We'll be standing there normally from noon till about 2, which you were this year. Give me your best shot. Final one is, when I die, I want to be buried in Brooklyn. That way I'll be able to remain active in politics and vote every election. Thank you for your time.
All right. So my name is Asit Patel. Good evening, everyone, again. I promised Bob, he asked me to stay over here, but I usually venture in and out, so if I do move out there, just remind me to come back here. But using condensing boilers effectively, where and how, what I'm going to be talking about mostly is common mistakes and misunderstandings associated with condensing boilers, the things that I see in the field. This is a picture I saw 2 weeks ago. I don't know about you, but if I were a shop owner, that's not the name I'll choose for my shop. Well, how is it relevant to this talk is, again, it doesn't matter what I think is right or wrong. It matters what one believes is right or wrong, right? The reason I say that is because we deal with a lot of building owners and management companies that insist that they want this type of a boiler or that type of a boiler. And even though we give them a proper guidance, they have made up their mind, and fine. You know, it is what it is. So again, these are all my opinions that I'm gonna tell you here. You may not agree with that, and that's fine. So the objectives of what we're gonna cover today is condensing boiler. We are talking about condensing boiler. What makes condensing boiler more efficient than the standard boiler? What is the true operating efficiency of a condensing boiler? This is what goes to the crux of this the presentation. You know, there are rated efficiencies of 98%, 99%, but what is the true operating efficiency that we find in the field? That's what we will talk about. What are appropriate applications for condensing boiler? You know, like Bob said, steam buildings, you don't use condensing boilers. But in order to really understand condensing boiler, you really have to understand the energy basics. So some of this you may find boring, but you know, stay with me for a few minutes, I promise. Heat transfer. First thing first. If you understand this, then you will understand condensing boilers better. Heat flows from object with a higher temperature to the object with a lower temperature till the equilibrium is established, right? We've always heard that, right? Heat flows from a higher temperature to lower temperature. Keep that in mind. What is a BTU? Everybody knows that, right? British Thermal Unit. That's great. Unit of measurement for heat energy. Amount of heat or amount of energy required to raise 1 pound of water by 1 degree Fahrenheit at room temperature, right? Atmospheric pressure, right? Approximate amount of heat when you strike a kitchen match and the heat generated by that. So again, keep that in mind. This is what we will need to sensible heat. What is sensible heat? Measurable heat, right? Measurable heat. The heat you can measure with a thermometer. When you heat water or cool water, the amount of heat added or removed is a sensible heat. For water, it's about 1 BTU per 1 pound for 1 degree raise. Okay, sensibly. That's something that you can measure with a thermometer. What is latent heat? Latent heat is not something you can actually measure with thermometer. Latent heat is the heat required to change state, right? So if you have a water, 200 degrees water, 1 pound of 200 degrees water, and you want to bring it to 212 degrees, how many BTUs do you have to add? 12, right? 1 BTU per 1 degree Fahrenheit. But to take that 212 degree water and convert into a 212 degree steam at atmospheric pressure, you have to add 970 BTUs. That's a, excuse my language, a boatload, right? I was going to say something else, but it's a boatload of BTUs. And why is that important? Because when you convert that water into water vapor, you add all those BTUs. When you convert that water vapor back into water, which is what's condensation, right? Condense, you actually get those 970 BTUs back. Again, why are we talking about this? Because combustion, right? Bob mentioned combustion. We have a combustion of natural gas. One of the byproducts of combustion is water vapor. We have water vapor going up the chimney all the time. Means what? We have 970 BTUs of heat going up the chimney almost all the time per pound of water vapor. And that's what we will be focusing on. What's a boiler? Look at the definition. Boiler is one that boils. I like simplicity. Right? Boiler is a vessel used for boiling. Boiler's simple. Boiler's like me. Low maintenance. Right? Feed it 3 times and we'll be happy. Boiler's not complicated. Right? What is condensing boiler? Why is everybody now worried about condensing boiler? Well, obviously, first of all, we're going to make sure we vent them properly. What's a condensing boiler? So boiler is a vessel. A condensing boiler is a boiler which has a heat exchanger made from a specific material that can withstand that acidic, very corrosive acidic solution resulting from condensation of flue gases. What does that mean? Remember that water vapor that was going up? If you actually remove that 970 BTUs from that water vapor, what will happen to that water vapor? It will turn back into water, which is condensed, right? That's what makes a boiler condensing boiler. And that's what makes a condensing boiler more efficient. You're actually taking that 970 BTUs that otherwise would have gone up the chimney, right? That's what's making it more efficient. So mostly these boilers are made out of stainless steel or cast aluminum, but also cast iron. And Bob Benson, condensing boiler. Any boiler can be a condensing boiler. If you have a hot water boiler, copper fin tube type hot water boiler, you run a 120 degree water through it constantly, that boiler will condense. Now, how long will that heat exchanger last? It's a different story, right? So you want to make sure that you're using the right boiler. What makes a condensing boiler more efficient? Like I said, capability to extract or recover that heat from water vapor, which is 970.3 BTUs per pound of water vapor, and combustion exhaust gases that otherwise ends up in the chimney. Right? And this is without compromising the equipment. We want to make sure we are doing this without compromising the equipment. Okay? So that's what makes a condensing boiler more efficient, if you're able to extract that heat out that otherwise is going up the chimney. Now I may get a little technical, and excuse me for that. I promise not to do that, but this is very important. The reason I say that is because here you look at the rated efficiency, it says 99%. What about the actual efficiency of that equipment? And the reason we have to discuss this is because I've actually gotten in serious disagreements or arguments with the design engineers, architects about efficiency, even energy engineers, about how much energy efficiency improvement you will get from replacing a standard boiler with condensing boiler. Actual efficiency. The actual efficiency of that boiler, or operating efficiency of that boiler, will depend on, first of all, the return water temperature. In order for us to get that 970 BTUs back out of the combustion process, the exhaust gas temperatures have to be below 132 degrees Fahrenheit, which is the dew point. And in order to do that, the return water temperature, remember, heat goes from what? Hot to cold. So if the return water temperature coming back, so if you have a stream of gas is going up the chimney, let's say at 180 degrees, right? And you pass cold water through that stream, which way will the heat go? From the flue gases into the water, right? Then you take that water and put it back into the heat exchanger. That means you get free heat, right? But only you're going to operate in a non-condensing mode if the return water temperature coming back is more than 135 degrees or 140 degrees. That will be non-condensing mode. You only condense when the return water temperature is below 132 or 135 degrees. In order to get to 99%, the water coming back has to be at about 60 degrees Fahrenheit. Show me a system where you have a 60-degree water coming back in a heating application. Not many, right? Not many. So you're not going to be operating that. Yeah, you may operate at 90%, 91%, 92%, most likely between 88 and 90%. Again, in a properly designed system. So what are some of the mistakes and misunderstandings that we find? Assumption that because the rated efficiency is 90+%, the system will operate at 90+%. Yes, you can get that in a properly designed system, where you can have a water circulating through the system at a much lower temperature and still satisfy the building's load. Buildings with a fan coil unit, buildings with a high mass distribution system such as cast iron radiators, radiant panel, radiant system, yes, you can get that. But less likely in a retrofit application, especially when we are talking about baseboards, right? The existing distribution is baseboard. Because if your existing distribution is baseboard, yeah, during shoulder months, like Bob said, you may be operating in a condensing mode or near condensing mode, but nowhere near here, where you have return water temperature coming back at 80 or 90 degrees. So yes, you will have a better efficiency of 88%, 89, 90%, again, during shoulder months, where you can get away with 140-degree water going out, 120 coming back. But in order to get proper amount of heat in a baseboard system, you probably have higher temperature water circulating through that system during design days, right? When it's 30 degrees and so. So true efficiency for 90+% of return water temperature has to be below 110. So think about it. In my system, am I going to have water coming back at below 110 degrees and still satisfy building's load? If the answer is yes, then yes, this is the proper application for you, and you will probably be operating in 90+% efficiency range. In retrofit application, condensing boilers are specified with high temperature distribution system baseboard, with an assumption that it will provide significant improvement over existing equipment. And I put this slide specifically because I had a major argument with a design engineer in Long Island. I was doing an energy audit for one of the Long Island Housing Authority, and they had a design engineer. I did the energy audit, and I said, okay, the base base condition is this. With the new equipment, the efficiency gain will be delta whatever, 5, 10%. And he came back and said, no. It's going to be much higher than that because I'm specifying a condensing boiler. I said, whoop-de-doo, right? 95%. And I said, do you know what they are circulating? First of all, it's a senior citizen building. What does that tell you about a circulating system? They're going to need a high temperature. On a 50-degree day when I did the audit, they were circulating 170-degree water coming back. And he is thinking he's going to get a major savings from condensing boiler. Not true. But I could not convince him. Fine, but I wasn't going to take that delta T in efficiency gain. So yes, there may be efficiency gain, but not that much. So again, we have to look at that. You could get away with a little bit better efficiency if you find that the existing radiation is grossly oversized for the building heat load. That means, yeah, you can circulate a lower water temperature and you may be able to still satisfy the building load. These are the things we have to look into before we just say blindly that condensing boiler will provide 96% efficiency. Again, for 95% plus efficiency, the return water temperature has to be below 80 degrees. In domestic hot water application, the system will operate above 95 degrees. Well, yes, it may. If you're taking a 60-degree water that is coming through, straight through the boiler, and you're able to actually make 120 degree coming out, that means you got a 60-degree delta T across that boiler. Means you better have a big fire to get that delta T. If you are using a condensing boiler for domestic hot water application through heating an indirect tank or a storage tank, you are not looking at 60-degree delta T because the water coming out of that tank is not at 70 degrees. The water coming back from that tank is not at 70 degrees, it's not at 60 degrees, it's probably 110 degrees. Means what? You are not at 99%, you're close to 92%. Hey, what's the difference, right? 92, 95. So again, not saying condensing boiler is not great, but be careful in what you are advocating, be careful in what you're promoting, and be very, very careful of what actual operating efficiency will be, right? The last thing you want to do is convince somebody to put in, and they have a misconception of that. You don't achieve your savings goals, and the person will never be satisfied, and you'll get a bad name, right? And the industry gets a bad name. So that's why we want to make sure it's promoted properly. So, when I got a call from Bob about a couple of months ago, we were saying, hey, have you done any condensing boiler installation in multifamily buildings? I said, yes. So I thought the presentation was about that. So again, some cases where we have done condensing boilers. 27-story building in Midtown, fan coil unit distribution system, something like that Bill has probably. According to them, they needed about 130 degrees water on a design day. Means when it's really cold, they only needed 130 degrees. So it was a great application for condensing boiler. Actually, they need a lot lower than that, we found out. So we actually did recommend in this particular case, it was a Con Ed high pressure steam conversion. So that means they had a high pressure steam coming in. We ended up putting the boilers on a rooftop. Again, no mechanical room downstairs. And we weren't going to run a flue pipe 27-story high. So we ended up putting the boilers in the rooftop, 4 2 million BTU boilers. This was our recommendation. So here are 2 boilers. There are 2 more in the back over there in the corner. You can't see. It was a really tight room. Another case study. 4 2-story buildings in Kew Gardens. Distribution is convectors. We put 4 400,000 BTU wall-hung boilers. Again, not against our recommendations, but the owner insisted. They wanted to be green. They wanted condensing boilers. Fine. So we did put a condensing boiler. So this was cast iron boiler, domestic hot water makers was removed, 4 wall-hung boilers were installed. What you don't see here in the picture is, in order to at least get a little bit better efficiency than what we were projecting, what you don't see here is a brace plate heat exchanger on the return side, where we were preheating the domestic hot water. So the cold water coming in would go through the preheat heat exchanger, brace plate heat exchanger, cool down the return water so that you can have a condensing happening. But again, that's during limited time, only when there is a draw on the cold water side or domestic hot water draw. Okay? But this was owner's choice, so we tried to do a little bit better. Another case study. This is very recent. Two last buildings are very recent. 7-story building in the Bronx. Distribution is baseboard, senior citizen building. They're doing a major rehab. We put 3 800,000 BTU boilers. Owner is required by the funding source that they must have condensing boilers. Against our advice, we showed them analysis after analysis, showed them that it's not a good choice from a cost effectiveness perspective. Yet the funding source insisted that they must have condensing boilers. Well, I'm not going to deny that. So they had these atmospheric boilers, 12 of them, you can't see, and we put 3 condensing boilers, 800,000 BTU. Same owner, another building, same 7-story, 96 unit, again, baseboard. We put 2 1.5 million BTU boilers. Again, the owner is required by the same funding source. So this, again, there are 6 here, there are 6 more in the back, so there are 12 boilers. We replaced with 2 1.5 million BTU boilers. But we have to be creative to get at least somewhat better efficiency out of it. This is not going to operate at 95% efficiency. I am telling you right now, I'm the one who designed it, I'm going to tell you, it is not going to operate at 95%. I was honest, we told the owner, and the owner understood that, but the funding source insisted that. So in conclusion, I want to make sure, I'm not saying that it's not a right application. In new construction, like Bob said, design the entire system to take advantage of the condensing boiler efficiency. So if you design the whole system, radiant panel, right? High temperature, low temperature distribution system means cast iron radiators, radiant panels, or whatever. You design the whole system around it. Make sure that there's a very little load requirement, and you put a condensing boiler. Yes, it will work, especially in new construction. Stick it up on the top of a roof, right? No flue gas. You don't have to run a chimney. You don't have to worry about flue gases, falling and tripping somebody on the floor. In a retrofit application, you need to ask these questions. Is the condensing boiler the best available option from energy efficiency improvement perspective? Am I going to get that whatever percentage of savings that I'm going to get? Is this the best option, or can I get away with a medium efficiency or standard efficiency boiler? Also, from a cost effectiveness perspective, is this the best option available for me? And Sam is going to go into discussing this a little bit more in the following presentation. One last thing, I'll throw this out. Steam to hot water conversion. If you are thinking about, if you have a building,
you have a project where you're thinking about converting from steam to hot water, especially a topic for some other day, but especially if you talk about Con Ed steam, you don't have a mechanical room, you don't want to run the chimney 7, 8 stories high because you don't have a chimney. Condensing boiler is a good application if you have a space constraints because there is no mechanical room. Especially if you have radiators, cast iron radiators. You can send a lower temperature water through those cast iron radiators and still get a lot of heat. If you have cast iron radiators and you're going to use those cast iron radiators, that may be one application. Use of non-metallic piping can also help with cost and installation. I don't know if Frank Rivera, I thought he was going to meet. But there are non-metallic pipe that you can use in a distribution system that will lower your cost, will help you, bend the pipes that you can't with the metallic pipes. Okay? Thank you very much.
You can contact me with questions, but one of the reasons I was really excited to do this one and grateful that they've had me here is that this room brings together people who need to be talking to each other, design professionals, and people who are going to be operating and maintaining the equipment that we're talking about. Please talk to each other, ask each other questions about your experiences, about what you can do, especially if you're designing systems. You need to take into account the people who are going to be working on these, who are going to be, even if they're not the service contractors, obviously, they're going to be calling them. How do we keep these things up? This is a non-technical presentation. None of this is trade secrets. It's not how to do it. It's about the questions that we need to be asking that make condensing technology different. What do we need to think about that makes it different, and what do we think about what do we not really need to think about because it's the same? As both Bob and Asit pointed out, this is not rocket science. It's designing a system that needs to work within certain parameters, and you have to know what those are and what you're designing. So read the manuals when you're designing. Go out and look at systems that have been installed. Ask how they've been operating. Take your own data and measurements. Really important. So this is an overview of how we design these systems. What are we looking for, and what's different with condensing technology? First thing we want to do when we're designing a heating system is minimize the load. Now, that means that the first step in designing the heating system has nothing to do with the heating system, right? This is about the building envelope. This is about doing everything you can to make sure that the load, that means the heat that we need to provide and the energy we put into it is as low as possible. If we minimize the load, we want to give the people enough heat. Complaints do not make for energy efficient systems. I'm sure the building operators here can attest to the fact that when you get complaints, you have to make do with something other than the design, especially in the short term. And you get enough of those, and that becomes the long term very, very quickly. Once you give them enough heat, you want to eliminate the choice to overheat. That means not letting somebody keep a zone valve open all the time. It means maybe not even allowing the zone valves to do anything by sending the right temperature water. We want to keep the apartment temperatures consistent. That means that Mrs. Fisher on the northwest side of the building gets the same, within reason, temperature as somebody on the southeast side of the building, different times of the day. A lot of that may not have to do with the type of boiler you put in. We want to convert whatever energy we're putting into the system into useful heat efficiently. This is going to deal with combustion efficiency. It's going to deal with insulation. It's going to be with getting from here to there. I want to minimize our ancillary loads. That just says, you know, if you got a bunch of extra crap you have to insulate and extra pumps you have to run, make sure that they're controlled well, that they get insulated, that it's reasonable. We want to protect the occupants of the building. This is something that Bob talked a lot about. Very important, and there are important differences with condensing technologies. We want to protect the equipment that we install and that exists in the system. We want to make it legal. That's pretty related to number 7 there. And then the kicker, we want to achieve the above and meet the client's requirements with a system that is as simple as possible to install, commission, operate, and maintain. That should be easy. So this is a schematic of a conventional boiler system that can meet those criteria. I've stripped away most of the details. So what we have here is a big conventional boiler, cast iron, whatever you want, something that's got a lot of water in it. It's got a domestic hot water coil in it. We have a 4-way mixing valve here. And then, you know, pumps to send it up to the building. Sometimes a little runaround pump here just to keep things moving on the boiler side of things at low loads. Keep this boiler at 180 degrees year-round. Insulate it well. Take your domestic hot water off of the coils. Same all the time. Control the whole thing on an aquastat. And then with this 4-way valve, you do a full outdoor reset and put the temperature out to the apartments, the radiators, at whatever temperature you need. That means we can go down to 90 degrees, or whatever's the lowest we can possibly send on a 54-degree day, without affecting the boiler performance or the domestic hot water performance. It's incredibly simple. So a lot of what we're going to do is kind of compare a condensing technology to that. I'm going to try to run through this stuff quickly. Most of the technological things have been covered here. Thank you all very much. But the point is going to be not that condensing boilers are God's gift to humanity, not that they're good, not that they're bad, just that as designers and as building operators, we have a job, and that's to understand what we're trying to do and then to do it well. Here we go. When we're talking about minimizing the load, there's nothing special here, nothing different here, right? Same thing, building envelope. Doesn't matter if it's condensing that you're going to put in, doesn't matter if it's conventional that you're going to put in. Giving enough heat. Nothing really special there, except for that this is something we're going to talk about when we talk about efficiency. You know, the sizing of the heat emitters. That's what people who went to engineering school call radiators. Asit mentioned you may want to make those higher mass, higher output, so that you can send lower temperature water or have higher temperature differences across your system. And the control sequence is going to be different for giving enough heat depending on whether we have domestic hot water in the loop or not. Eliminate the choice to overheat. So this is an interesting one. Everybody wants to put in zone valves, and that's great, but I'd rather just not give people something that when they leave the zone valve open all the time, or when it breaks, will heat their apartment up to 90 degrees. And we've done so many projects where this is the case. You know, they send 180-degree water all year round or all winter long, and everybody has the zone valves open. Asit mentioned this is very common with different populations that you have to look at. Who's going to occupy this building? Is it going to be seniors? Is it going to be predominantly people from a country that is very warm and want things very warm all the time? I mean, having people from Russia and the Dominican Republic in the same building is like, you get a lot of problems. A lot of problems. Go to Coney Island in like a design day, and you've got all these guys walking around with just a fur coat on, a fur hat on, sorry, and then other people who want to be walking around inside barefoot and naked those same days. Like, you got to think about who's going to be occupying this building and make sure that you can give them a system that works for them. So water temperature is the major thing. Don't send something too high that when something breaks, which it inevitably will, that it's gonna cause a lot of waste. Asit touched on this. Fan coils and heat pumps can be a really good application for condensing boilers here, because you're really just putting a much lower and often constant temperature, and letting the fans do the work. That has other implications for energy usage, depending on who's paying for it and who suffers the consequences, which is all of us. Keeping the apartment temperatures consistent, there's nothing different there. That's just that's about the distribution system. That's going to be the same with condensing technology or conventional. You've got to balance the systems. That's a completely separate topic, but it totally has to be done. Otherwise, you don't have a chance. Converting energy into useful heat efficiently is probably the biggest thing. Asit was talking a lot about combustion efficiency and how we get there. With conventional boilers, we have to worry that the water temperature coming back is too low. And with condensing boilers, it's exactly the opposite, right? We have to worry about it being too high. Asit showed a similar thing here. Not gonna get into that too much, but there are methods to do this. Asit mentioned both of them: low temperature distribution and trying to preheat your domestic hot water. The first one is by far a better strategy because, again, as Asit said, the domestic hot water is based on the load at that time. And that's intermittent. And you're going to have different populations in every building. People who, not that there's that many third shift workers anymore, but you have to look at how domestic hot water is being used in your building for that. Take measurements, flow meters, great. What if we're not touching the distribution system? This is a big thing. We just saw all these pictures of condensing boilers going into places where it's not a good application for it on the surface. This is one building where we just put in a condensing boiler. Maybe it was our choice, maybe it wasn't. But we have been watching this for the last several years now, and they're consistently saving 25% from where they were before. We didn't touch the radiation, didn't touch the distribution in the building. What happened here? What we did was, this was lucky because when we designed this system, I happened to be there on an extremely cold day and could experiment with the water temperatures that we were sending. And I also found that in this building, they had, you know how contractors sometimes will just put baseboard along the entire perimeter of a room? We had that, which is pretty fortunate circumstances because it's basically like panel radiation. It's something that gets us a higher temperature drop, and we can send lower temperature water through that. So we didn't touch the radiation here. All we did was commission the system to make sure that we're sending as low as possible. And we ended up being able to send 140 degrees on a design day. So that's pretty great. You can't do that in every building, but you can get closer. Minimizing the ancillary loads. Nothing special here with condensing technology, except for that you're more likely to have more pumps involved, more different loops, zones, separation. So just make sure that the pumps aren't killing you. Protect the occupants of the building. This is just another picture that probably belongs in Bob's memoirs here. This is an improperly vented condensing boiler that has eaten through the pipe it's in and is dripping carbonic acid on a gas pipe. My colleague Mike Brusick took this picture in a building. That's a big problem. You know, I don't want to be in that. I don't want to be that designer. I don't want to be that installer. ICE is another one that Bob Daly showed. Protect the equipment. This is a big deal here. So I'm at the 2-minute mark. I gotta speed up. A lot of this stuff we really need to be careful to protect. Low water content boilers. We're talking about heat exchangers that have a gallon of water in them. And many of these heat exchangers, those would be converting from boilers that had 800, 1,000 gallons of water in them. You can do anything to those. And they just kind of keep working. You know, we deal routinely with 50, 60-year-old boilers in New York and New Jersey that are totally doing their job. It may not be as efficiently as possible, but they've been at it for a long time. Watch your flows, water quality, filtration. With those small heat exchangers, stuff clogs those up really quickly. So anything that would just fall to the bottom of a big mass of water in a Scotch Marine or a cast iron boiler becomes very problematic in a very small heat exchanger. And the venting, I'm not going to go over that again. Neutralization and drainage, very important. Pitches, making sure you're not eating through anything. There's a major deal with operating this machinery is, you know, the neutralizer, that limestone needs to be changed out. These generate a tremendous amount of liquid going through them, and if that neutralizer isn't changed, then you end up sending that acid to the drain, and now you're eating out your drain pipes. And then all of a sudden, in the middle of winter sometime, when every plumber is already slammed with emergency calls, you have drain pipes that are going bad and stinking up the whole building. Make it legal. This is Bob's territory. Protecting the occupants of the buildings and making things legal, he's extremely helpful with. Take it seriously. Ask the right questions. I'm going to skip through this stuff. Okay, so the kicker. Bob, do I have an extra 2 minutes here? Thank you. Y'all get up and leave if you need to. This is hard, and there's a lot of tricky terms in here. First of all, the client's requirements. The client's requirements are pretty big deals, you know, budget and the timeline. Condensing equipment and the venting to go along with it and the installation can be much more expensive. So if budget is an issue, we really have to watch out for that. The timeline. You can't go pick up a 2,000 MBH Airco boiler from the supply house. It's got to be ordered, and it takes a long time. So not always great for emergency replacements. You gotta consider the contractors who are available to do the job. A lot of contractors still aren't very engaged with installing these type of systems correctly, and they require a lot of care because it's not just a big cast iron kettle with a fire underneath it. This stuff needs to be installed right, commissioned. You can break these systems the first time you run them if you're not careful. by not filtering it properly. So you really want to be confident that the contractor who's going to install it can do it. And you want to make that relationship happen early. With a lot of these new technologies, the most important thing is not to write the perfect specs or to make a contract that really busts somebody's butt if they don't do it right. The most important thing is to make those relationships early in the process and make sure that they're on board with doing this job. And this is particularly important if you've got clients or if your building owner will only allow certain contractors to bid it or is almost guaranteed to choose a certain one. You know, if you have the wrong contractor, don't design a condensing system if they're not willing to meet the requirements. By the same token, who's going to be commissioning it? These things have to be started up properly. It's not enough just to have the factory representative come out and give their blessing. You have to measure the flow rates. You have to get the temperatures in the units right. And we potentially have more flexibility with that with condensing boilers, and we need to make sure that they're well protected and operating well. And then assessing the operations and maintenance capabilities of the client. There's not a whole lot, it's not complicated operating and maintaining this equipment. It's just a change from what a lot of people are used to. And a lot of organizations, especially in New York City real estate, don't really change, or at least don't respond well to it. So you really want to make sure that somebody's willing to go that route for the long haul. So that's related to why don't we just put them everywhere? If it's the wrong application, fine. If it's the expense, fine. The expense and the complexity of venting. Fear of equipment failure. This is a big thing, right? If we can't, if the equipment is gonna fail, then which it's more likely to do. Like with the more greater efficiency comes from greater precision. And anytime you have a machine that's very precise, it's easier for it to fail, right? More moving parts, tighter tolerances. And we've got computers in these boilers all of a sudden. Like that's a big change from a big cast iron kettle with a fire under it. We have computers in our boilers, right? If that chip isn't there in 5 years, I mean, I don't have a computer from 2000 that still works. But when everybody's doing these calculations, well, Fannie Mae puts a 20-year estimated useful life on it, right? Still, these can work. They need to be maintained. Think about it. Lack of confidence in designers, installers. So the good applications, these have already been mentioned, but rooftop boiler rooms, any place you can just put a stub stack and not worry about the getting the exhaust out of the building is great, and about getting air into the boiler. Low temperature loops, where you know that you're always going to have that, usually a great application. And then, again, distribution, where aggressive outdoor reset or a very high temperature drop or both is reasonable to expect. None of this stuff is rocket science. Those changes we all just went through, where we need to focus our attentions when we're speccing condensing technology, it's not very complicated. You just need to read the manuals, and sometimes you need to call the manufacturer way more than you'd like to get them to respond to the question that you have. But it's totally doable, and I really encourage everybody in this room to talk to each other to make sure that when you're designing jobs, or if like Bill Aristobulus, where you're pushing it for your own building, to help make sure that you get the right design, that it makes sense for the occupants of your building, and only the superintendent or the resident manager is usually one of the best sources of information about that. So I think Camilla is going to come back for questions, right?
So the format for the Q&A is that we will people will ask questions. I'll repeat them so everyone can hear them, and our speakers will answer, of course. The question is, how often does the limestone have to be changed out in the system?
Read the manual. It will tell you what you need to know. You can get different replacements for these. They may all be different.
Paul's question is any simple answers to the question of payback? I think that's a pun, but go ahead.
It depends. Our building spent a lot of money on that system, but we also changed the distribution system, not because we needed to make it more efficient. It was rotted and it had to be done. So when you talk about payback, that's great. But when you have pipes that are falling apart, that are paper thin, you have no choice. So the payback on the boiler itself, it was fairly reasonable. What cost a big amount of money was all the piping that had to be replaced, and all the insulation that was never there in the first place. So all these things added a great deal to the cost, but it was, you could not do it. You couldn't say, well, we're not going to do it. It's not possible.
And I think that's a really good point that Bill is making. So you're in buildings, the systems are coming of age, they have to be replaced. That's part of this discussion, is the opportunity there.
Another thing about payback, like this is a really great reason why this is a lot of designers. There were, I think, 90 people when I counted who seemed to be from the energy industry, and then more than 100 people from 32BJ here. Payback is about how you maintain and operate the system. There's no payback unless somebody's paying attention to that all the time. So that's where 32BJ comes into things. I'll tell you that when we're in 32BJ buildings, we're much more likely to recommend something where there might be a longer payback, or where we can where we know that something needs to be maintained properly in order to be sure of that.
We didn't ask him to say that, but that was good. Any other questions? Yes, sir. So the question is, on the 27-story building that a seat worked on for a retrofit, did he have to run a 27-story, you're talking about the exhaust pipe? Right, for the gas line up to the boiler system on the roof?
The answer is yes. And not only the gas pipe, we also had to run supply and a return riser all the way down and pick up and connect to the other building that was about 100 feet away. So yeah, there was a lot of piping involved.
Good question. Yes, please. So the question is, Sam, what's your problem with zone valves? And thermostats, aren't they required by code as well? Go ahead.
I'm sorry if I wasn't clear about that. I really like zone valves and individual temperature control, but the point is eliminating the ability to overheat. I would like for people who are too hot to be able to turn their heat down instead of opening the window. When you do that, then more heat basically just gets back to the boiler faster and turns it off. And we can save energy that way instead of putting it out the window. So the point is just to send water temperatures that don't allow somebody to overheat. Not that we want to take away temperature control. That being said, zone valves also need maintenance, and you need to get into every unit to be able to do it and check it. So they have problems, but I'm pro.
I also pushed for BTU meters on each heating unit, and it didn't happen. But that would be a great way to punish the hogs. If you want it hot, put it as hot as you want, but you're going to get that monthly bill. But the building chose not to do that.
So the question is, can using biodiesel minimize the amount of acidity in the exhaust?
I don't know the answer to that, but
I've seen very few oil-fired condensing boilers, and the only place I've seen them is in Broad Channel, because when you build a new place, you have to meet the energy code. It's very difficult to meet the energy code unless you have a high-efficiency heating system. So they use condensing oil-fired boilers. That said, they're rampant, especially kerosene in Europe, and not so much biodiesel, but I'll say #1 fuel. So it's coming, but it's not there yet. You cannot sidewall biodiesel or number 2 oil except rooftop. So it creates some other channel, less opportunities. What I am seeing is heavy market penetration in smaller apartment houses, say 8, 10, 12 units, getting rid of one boiler, putting in one in each apartment. You can mount them in the living room wall. You cannot put them in a bedroom. That's a quick way to kill somebody. So, but if done the right application, they're wonderful. A lot of some good examples here. A lot of great ones around the city where they're done properly. Some real bad ones that were bad choices. But if done correctly, if done by a design professional who's done it before, I see a lot of great opportunities. I've done a number of senior citizen projects in the past, a 12-story senior citizen project, 2 zone valves, 220 units. Can you get 100 senior citizens to agree on anything? So we had east and west. You put in a zone valve in each room and it cut their bill in half because we had to keep it at 80 to keep the tenants warm. So the windows are open basically in 75% of the units. Know your customers, which is key, we all talk about. You're part of the solution, so you can feed the design professionals the key information they have to know in order to design it properly.
Now, I want to just throw in another question on this because the energy code came up in this. How much is that a driver to the idea of using something like a condensing boiler? Does anyone have a comment on that?
On new buildings and gut rehabs, it's almost 100% market saturation. So if you're putting up a new building, you're putting in a condensing boiler. It allows you the opportunity to do other things like a bit more glass, perhaps balconies or other opportunities. So I'm seeing virtually no buildings other than like a hospital or some other things that have the standard boilers. So if you're putting in a residential building or if you're running a residential building and it's new or going through a major rehab, it'll be a condensing boiler. When you look at the heat for the multiple dwellings in New York, they were designed one way. If those built up until the 20s, it was designed to have windows open in the winter. The fresh air is going to make you healthier. This came after the Spanish flu in World War I. Put in loads of radiation, tremendous amounts of radiation, so you can cook eggs all over the place. So you have this tremendous overload. Then you have a huge boiler in the basement that isn't needed. The size could be reduced dramatically. The energy code for new buildings nails all this. It does not deal with the existing buildings. So if your building is going to go through a major rehab of the heating, take a look at it. You heard a great example about improvement in comfort, improvement in noise, improvement in so many different ways, and comfort for the people in the end, less sound. There's great opportunities. If you know your building, know the clients in the building, you can feed the design professional that key information that'll be make or break for some systems or subsystems that you may want. Swimming pool, great opportunity for condensing boiler because you're heating it, that heat sink is down about 80. It should all be condensing boilers. A lot of opportunities if you look hard.
Gentleman in the back. So the question is, on a 5-story building, you're not able to put it on the roof. So you're asking about what the issues are about running the exhaust flue up to the top of the building, I guess. Is that correct? Okay.
In a 5-story building, it's probably just a cost issue. Assuming you have a backyard someplace, but you can't use it depending what you're doing with the domestic hot water as well. I mean, if there's a way to use an existing chimney as a chase, you can't use the existing chimney as the chimney. But if there's no other piping that's going to be in there, you could potentially use it as a chase. So there are still logistics of it. Where do you run that? But it's more just a cost issue.
And if you don't have a chimney that you can use as a chaseway, and you have to put a new flue pipe, if you're going to put it external, it has to be double wall, which just add to the cost. So at that point, it's literally a cost issue.
Any other questions, sir? Okay, so a couple questions there. One, when did the energy code become a driver for condensing boilers? And is it really possible to use condensing boilers in existing buildings and get your money back? Is that right?
Okay, the energy code only came out about 10 years ago, less than that. And then the code has gotten more strict as we go along. So the latest energy code requires you to meet certain requirements for the energy use of the building. If you're going to meet that, and you can get 10% less energy out of a boiler using condensing, it allows you to use that energy somewhere else, like more glass. And people love glass. So that's why the switch to it. It's not that you can't use it, it's just a choice. So that's the piece why I'm seeing all of them. Gut rehab would do the same thing. It's how you achieve your energy balance. Now, I've seen condensing boilers in older buildings. You have excellent talking bear, where they've worked really well, and I've seen where they didn't work at all because they were designed. If a condensing boiler is operating at 180-degree water, you're getting nothing out of it. You just wasted your money. So payback, hard to say. It's only if you're doing a replacement would typically pay, and replacing a system.
I think going back, if I actually came across saying that it's never a good application in a retrofit application, that's not what I meant to say actually. You always have to look at every scenario, right? You have to analyze. Like Sam talked about his example. You have to look at the building, you have to look at the attached radiation, and you have to look at the heat load requirement of the building. So with an existing building, even with a base put application, if the load requirement isn't there and the existing radiation is already grossly oversized, that may be a good application for condensing water. So you have to look, building by building. I hope that helps.
So Camilla, should we take a couple more questions and wrap up? Is that right? Okay, very good. Any other questions? Anne-Marie? So the question is there savings in operations between a standard boiler and a condensing boiler? We've stumped the panel.
Hi, Anne-Marie. There are different parameters that affect that in every building. We talked about ancillary loads. If you used to have a system where you ran a couple of pumps and those just blew through the boiler, full flow, and also through all the radiation in the building, depending on how those were sized, it could be that when you design a system that's primary, secondary, and you have different pumps operating at different times and more piping and valves that are uninsulated, that you could end up with higher electric loads. So not as much about the savings, but about just what is the practice? What is the O&M? Yeah, that's a great question. Read the manual. Yeah, it's such an awesome thing to do because it tells you it tells you what you need to do to keep the thing operating. And not only does it tell you what you have to do, it tells you how often to do it. So if you had some sort of program, say, to remind you when you needed to maintain certain items, like log check or something like that, it would be really easy just to program that in to that and say, okay, I need to change my filter. That's not complicated. We change filters in all sorts of settings, but all of a sudden when you've got one in your boiler, that's a little different because our last boiler didn't have a filter, did it? Right? So you have to know that stuff. You make a list of it. You say, how often do I need to do this, and how do I remind myself to do it? It's probably like a 5-point list. It's not rocket science. You just need to read the manual.
So the question is a condensing boiler more time consuming for the superintendent in terms of O&M?
If no is the general answer, but I have seen scenarios where, because it's not set up properly, because it was never commissioned, because there's not a good systems O&M manual, you don't have anything to compare it to. The operator doesn't know what the right settings were, and all of a sudden you've got a new system that was put in July, and nobody comes back to. Nobody's just no installer of his or her own volition is going to come back in October and say, well, gosh, I better see how this thing is working, right? Well, there are probably 3 installers in the city who would do that. But in those scenarios where all of a sudden an operator has a completely new machine on his or her hands and hasn't been trained, the thing itself hasn't been set up and may not even work. It could be that whatever he or she does isn't going to work.
That could happen to any equipment.
Right,
So-
so I have seen that scenario with condensing equipment. I don't think it's unique to condensing equipment. It's just that that's where we see the problem.
So, yeah.
No. It's the same as an air conditioner. It's like change the filter, blow down. You're usually blowing down the filters, not the boiler, the strainers, dirt separators. But no, it's general maintenance. No.
So I think at this point we want to wrap up. So I think one of the main themes here is that we're seeing a different type of boiler showing up on the market, showing up in new construction, new buildings, but also starting to show up as a possible application in existing buildings, and you're part of an industry that is changing. So I thank all of you for coming tonight and learning about this and continuing to be involved and continuing to be part of the change. Thank you.